Hello and welcome to Mr. Tompkins EdTech. With 2 papers down and 1 to go, many of you have been asking about my predictions for topics likely to come up in paper 3. So I thought I'd make this quick series of videos compiled from questions covered in my practice papers and past paper walkthroughs. In each video I've taken one topic I think is a dead cert to come up on paper 3 and created a compilation of all the questions I've recorded on just that one topic. Question 13 has an identity and it's asking how many values of x is x multiplied by x plus 4 equal to x squared plus 4x. Well, the very fact that this is an identity, it's got 3 lines there, not 2, which makes it an identity. That means it's true for all values of x. That's what an identity means. So that's done. In question 23 we are given an identity. 2x squared minus 20x plus c is identical to a open brackets a minus b all squared plus 3b. Now take care here, this is not an equation that you want to solve. You're not wanting to be moving things over that identity from one side to the other. What you want to do is you want to take one side and make it look more like the other so we can compare all the coefficients and read out the values of a, b and c. So I'm going to take the right hand side of this identity and I'm going to make it look more like the left hand side, and then so we can read off the values. Okay, so I'm going to start off with the right hand side, and that is equal to a lots of x minus b all squared plus 3b. Now multiplying out the brackets, if you're not very good at brackets you might want to write those 2 brackets out, x minus b, if that makes it easier for you. And then so that's a lots of x squared minus bx plus b squared plus 3b, which is a lots of x squared minus 2bx plus b squared plus 3b. Okay, removing the brackets, multiplying everything inside the bracket by a, I'm going to get ax squared minus 2abx plus ab squared plus 3b. Now I finish multiplying them out, you'll see that I've got something to do with x squared here, ax squared, and that's got to be equivalent to my 2x squared in my original identity. I've also got something to do with x. I've got minus 2abx, and that's got to be equivalent to that minus 20x there. And I've got some numbers on the end, some constants on the end, which must match up with my constant on the end of that. So I can pair them up. I can say, well, if ax squared is equal to 2x squared, then a is equal to 2. I can say that the 2ab must be 20, and I know that a is 2, so that means 2b must be 10, so b is equal to 5. And I know finally that ab squared plus 3b must be the same thing as c. So c equals ab squared plus 3b, which is 2 lots of 5 squared plus 3 lots of 5, meaning that c is equal to 2550 plus 1565. So c is equal to 65. In question 17 we have an identity. We've got 2 expressions and we're told they're identical to each other, and we need to work out the values of a and b. Okay, just take care with these sorts of questions. This is an identity, so it's true for all values of x. We're not trying to solve for x here or anything. So we're not going to be bringing things, crossing things over the equal signs and trying to drill them down onto the answer. Instead, what I've got is, I've got two different expressions involving x and some other things, and I'm told they're identical, so they're equal to each other for all values of x. So what I'm going to do instead is I'm going to take one side of the expression, and it's usually a good idea to start with the more complex looking one and make it look more like the other side. So I'm going to start with the left hand side of my expression, and I'm going to try and simplify it out by multiplying out all the brackets and collecting all the like terms together, and then try and make it more look like the other side so I can compare coefficients. Okay, so first up, removing the brackets using whichever method you like best. I'm going to go for two eyebrows, a nose and a mouth. So 3x times x is 3x squared. 3x times minus 2 is minus 6x. 1 times x is x, and 1 times minus 2 is minus 2. Don't forget my other two terms, ax and b on the end. Okay, now I can start collecting like terms together. I just have the one term in x squared, so I'm going to just leave that at the front. But for my terms in x, I've actually got three different terms. I've got a minus 6x here, a 1x here, and an ax here. So I can say that what I've got is an a plus 1 minus 6, which is minus 5. I've got a minus 5 lots of x. And then finally, my constants on the end, I've got a minus 2 and I've got a b. So plus b minus 2. Okay, so you can see now I've multiplied out all the brackets and I've collected all the like terms together. So now I can start comparing it with my right hand side above. So my coefficient of x squared matches with that coefficient up there. So we're saying that this is equal to 3x squared plus 8x minus 5. So that bit and that bit are identical. And then, so my a minus 5 lots of x has got to be equivalent to that 8 there. And finally I've got a b minus 2 on the end, and that's got to be equivalent to this minus 5 here. So now I can equate coefficients. I can say my 3's are equal to my 3. So comparing coefficients, I know that a minus 5, my coefficient of x, must be equal to my coefficient of x, must be equal to 8, which means that a must be equal to 13. And my blue ones, my b minus 2 must be equal to minus 5. So b must be equal to minus 3. So just need to write that in the box below, 13 and minus 3. Question 3, circle the identity. Well, identities have 3 lines like that, so that one is the identity. The others are an expression, an equation, and an inequality. Question 9, work out the values of a and b in the following identity. Okay, so we've got a complicated left hand side and a little bit more of a straightforward right hand side, and we need to work out the values of a and b. So basically we're going to be comparing coefficients here, but before we do, let's see if we can simplify the left hand side a little bit so it's a bit easier to compare. So the left hand side is 3ax plus 6 minus 4 lots of x plus b. Now removing the brackets, I'm going to get minus 4x minus 4b. I want to collect the like terms together. So I'm going to get 3ax minus 4x plus 6 minus 4b. and then factorising out the x, I'm going to get 3a minus 4 lots of x plus 6 minus 4b. Okay, now that is identical to 11x plus 14. So what I can do now is I can say, well, this coefficient of x here, if it's identical to the other expression, must be 11. And this constant I've got on the end must be the same thing as that constant over there. So I can form two equations now. I can say that 3a minus 4 is equal to 11. And I can say that 6 minus 4b is equal to 14. So I can, well, they're each linear equation, so I can solve both and find an a and then b then, can't I? So 3a is equal to 15, making a equal to 5, or 6 minus 14 equals 4b. So minus 8 equals 4b, making b equal minus 2. So b is minus 2 and a is 5. Check out my other predictive topics by clicking on the card appearing here. Also, you can check out my practice paper walkthroughs by clicking on the card here, or you can even go through actual past papers by clicking on the card over there. Good luck in your exams, and I'll see you next time.